another episode of Solidity Fridays on a Wednesday because we again got too excited. And I'm joined today with Pablo from UMA
Hi, everyone.
and Tam, our OG. So Tam, do you want to give a quick intro, and Pablo, you too?
Aringus, I work at Alchemia and Web3 Sanctuary as a course convener. I'm a Solidity developer. I really am a fan of UMA, so I'm quite excited to look at the optimistic oracle today.
Cool. Yeah, so I'm Pablo Maldonado. I'm a software developer, smart contract engineer at UMA. I've contributed to the last optimistic oracles and DVM 2.0 contracts that we're going to present today. And I'm very excited to be here with you.
Cool, amazing. So I'm going to hand it over to Pablo. And yeah, we're very excited to run through everything.
Perfect.
Cool. Are you? Yep.
Yeah, so I'm sharing my screen already.
Perfect.
And so, well, first, these are the UMA docs that can be found, docs.uma.docs.xyz. And today we're going to present and talk about the optimistic oracle with some examples together with the DVM 2.0, which is the data verification mechanism that we're going to see at the end of this presentation. No? So first, I'm going to present this diagram that is, I think, a very good way to start. And I'm going to, so the optimistic oracle, especially the optimistic oracle V3, has a new pattern, a simplest pattern compared to the previous one, the OO V2, that is still usable. But in this new pattern, we have the idea of an asserter, which is a person, a smart contract that wants to assert a truth about the outer world, or it can be also Web3 data. And this person, this smart contract, wants this information to be stamped, like certified by the optimistic oracle, so it is safe to use and build things on top of it. No? It could be a prediction market, an insurance smart contract. The use cases are endless. No? So it all starts with someone asserting something. To assert, this actor needs to bond the data that is being asserted with an amount of tokens. And this is to ensure that this person doesn't lie, right? So whenever someone asserts something, like let's say I'm asserting that the price of Bitcoin was $3,000 yesterday at 3 p.m., for example, there is a challenge period that starts that can be configurable, but let's suppose it's 2 hours. And during this time of period, anyone can dispute my assertion if this person thinks it's wrong, right? But in the case of not being disputed, this assertion is approved after the 2 hours challenge period, no? And it is approved optimistically because we assume that it is right, no? But in the event of a dispute, we can also have this second actor, the disputer, that when watching my assertion decided it is wrong, he also needs to bond his dispute. So again, putting the same amount of money to back his dispute, his action of disputing. And at this moment, so these two actions were within the scope of the optimistic oracle, but at this moment, we are escalating the dispute to the data verification mechanism, which is a different smart contract, a contract called voting V2, because it's not only for verifying data, but for voting things in general in UMA. And it is then the responsibility of the UMA token holders that through a vote will determine what was the correct resolution, what is the correct resolution of this dispute. and they are doing so by voting in an unbiased way. So everyone is voting independently with their own criteria, with a commit and reveal pattern that we're going to see later. So once the vote is resolved, there are two different scenarios. The disputer was right. In this case, the disputer receives his bond back, but together with half of the bond of the asserter, and the opposite goes for the asserter. If he was right, he receives back his bond, and together with half of the disputer asserter. And that's how the system is economically incentivized and how this like data stamping mechanism works, right? So I think we're ready to jump to the code. And so, as I said, we're going to start with the optimistic Oracle v3, which is the latest version of the Oracle, the one that implements this assertion pattern. And well, as always, nothing strange here. We start by importing some libraries from OpenZeppelin. It is an ownable contract, SafeERC, some interfaces, so mainly the interfaces that this contract implement, and also interfaces of other contracts that we're going to interact with, together with some functionalities that this contract uses. So this contract, as the notice says, it's used to assert truth about the world that are verified with an optimistic escalation game. No? It is this game that we described previously of someone asserting, eventually someone disputing, and this vote that occurs on chain. So again, nothing strange here. We are just using SafeERC for everything related to ERC tokens. And here we declare the finder. This is a contract used in UMA to basically find contracts. No? It's different than the proxy pattern. It's more like a finder, no? Where addresses are stored, and with contract names, we can retrieve them. We also cache some values here, like the Oracle being used. The Oracle is the DVM. It is the voting contract. We call it the Oracle in the optimistic Oracle, which is like the second layer of the Oracle, if it makes sense. We also cache the currencies that can be used for bonding. No? For example, we can bond, so we can back the assertions with USDC, with stable coins usually, also with WETH. We have a bunch of currencies that can be used, but they need to be approved before being able to use them. Here is where we store the assertions. So any kind of truth being asserted from the outer world. Here we have the default identifier. We can have an identifier is a way to associate the assertion, the kind of assertion that we are creating with a set of rules that have been also approved prior to the execution of the assertion and stored. In our case, it's stored in a GitHub, and we call them UMIPs. And they basically describe more in detail how the assertion should be created, but also they guide the voters in the event of a dispute to correctly decide how to evaluate and vote on them. No? But it is ultimately the voters that decide, independently of these UMIPs. We are also storing the numerical true. It's represented by 1 because the optimistic Oracle v3, as opposed to the optimistic Oracle v2, it only outputs, it has a binary output, true or false. That's it. That's why we say that this pattern is simpler.
I see. Sorry,
yeah.
Can I interrupt there?
Yeah,
why is it an int 256 and not a uint? What is false, a numerical false then?
Yeah, It is, yeah, numerical force is any other number different
Okay,
than one.
negative or non-1. I see.
Yeah,
Okay.
exactly. And it is a int. It's a good question. It's because of old versions of the optimistic oracle and how the DVM works to be backwards compatible with every kind of oracle. That's why we require it to be
Okay, thank
int
you.
200.
It's interesting.
Yeah.
Sorry, could you please zoom in a bit
Oh, yeah, of
as well?
course.
Oh, that's perfect. Thank you.
Perfect. Okay, so the constructor of the contract is quite simple. We only are passing the default currency. I think it's USDC, and the default liveness, which is this time window where an assertion can be disputed, together with the finder. And that's it, no? Because the finder can be used to find any other contract that we require in the rest of the logic of the smart contract. We also have some admin setters here where we can configure some values like the burn bond percentage, because as I said, after a dispute is resolved, part of the bond is sent to disputer or asserter, but half of it currently, so 50% burn bond that we have is sent to the store, which is another contract that represents the UMA system. No? And it's kind of can be seen like the cost of triggering a vote, no? Which in the end it requires effort. No? And yeah, so we also have some sync functions here to update the cache that we saw previously, and that's it. And so let's present the first and the simplest version of assertion that can we do in this smart contract. And it is the assert truth with defaults. It is a simplified version of the assert truth. As we can see, it has much more arguments. But in this case, we only pass the claim, which is the byte encoded truth or message that we are asserting. For example, yesterday it rained in London at 3 p.m. And the asserter address, which is the account that is going to receive back the bond after settlement. No? So after the 2 hours in my example, if not disputed, this address will receive back the bond. Bond that, by the way, is currently set configured to 250 USDC. So that's the size of the bond. And so this function basically is just a wrapper of the assert truth function that is just defined a little bit below. And just sending default values, most of them 0 values, together with default values, the minimum bond. But let's go to this function to better describe every single parameter that we can pass to the more advanced function, if it makes sense. So here again, we can see the claim as this message, this truth that is being asserted. Again, the asserter, this account that receives back the bond. We can configure the callback recipient because during the life cycle of an assertion, there are different callbacks that we're going to see later that can be sent to a smart contract, so it can react to the life cycle events. We have also the escalation manager, which is a different smart contract that we are also going to see later. But basically, this smart contract allows to have fine-grained configuration, more advanced configuration of how the assertions work, how the dispute of an assertion is escalated we are going to see how we have different options there. What do we do in the case of, in the event of an assertion? Do we want to discard it completely, or we want to wait for the resolution in this data verification mechanism that we mentioned earlier and get back this result? So these are options that can be configured. But in the simplest scenario, and I will say most of the projects, when starting to build with the optimistic Oracle, don't need to configure this escalation manager. They can use the simplest version of the assertion, or maybe use this version if they want to specify, for example, other parameters. But let's continue with the rest of params that we can send to this function. Also, we have the liveness, which is the time window where we can challenge. The default one is set to 2 hours, but it can be more or it can be less. No? And this is a kind of responsibility of the project using the optimistic Oracle to configure it properly. No? We also can set the currency, that can be anything, the currency to bond with the assertion, and the bond amount. The bond amount can also be increased. In the simplest version, we use the minimum bond, which is $250. But the protocol, the user of the Oracle can decide to increase it if they want higher economic guarantees, let's say, no? Or they want a bigger commitment, no? from the disputer eventually when disputing. The identifier can also descend. At the moment, we only have one identifier, the assert truth one, which is the simplest one. And also we have the idea of domain ID, no? Which is an optional, again, parameter that can be used to group, for example, assertions under a domain name, no? And have maybe in the escalation manager different set of rules to handle them. But this is, I think, an advanced functionality that goes well with the escalation manager configuration. And finally, this function, and the previous one also, returns the assertion ID, which is the unique identifier that represents this assertion in the optimistic Oracle. So let's start by reading the code of how an assertion is made. We first start by getting the block timestamp that is used to uniquely identify an assertion. This timestamp, together with the claim, the bond, time, liveness, currency, callback recipient, escalation manager, and identifier, are used to uniquely identify an assertion. It's basically KeyCAC 256 hash of all these arguments. Then we have some requirements. The asserter should not be the address 0. The assertion should not exist. So we cannot assert exactly the same thing. If we wanted to assert 2 times the same assertion, we will need to do it in different blocks to have different timestamps. Here again, we validate the identifier, the currency, the bond needs to be more than the minimum, and that's it. We can store in the state of the contract the assertion, which is a struct that we don't need to go to the definition because it's quite obvious here how it's configured and defined. So we have the escalation manager settings that here are defaulted to the default values. So I think it's a good time to describe them. So the escalation manager settings, we have different booleans, basically defining different behaviors. The first one, arbitrate via escalation manager, basically allow us to use a different data verification mechanism if we want to. by default, when disputing an assertion, we escalate it to the UMA voting V2 contract, where all the UMA token holders vote on it to resolve the dispute. But the protocol implementing with the Oracle can decide for all the assertion or for particular ones to use their own Oracle. And this Oracle could be anything. It could be a multisig just deciding the resolution, but it could be maybe another Oracle that combines different tokens to have different, for example, it could combine the UMA token with another token and combine the vote power of both to increase the TVL, let's say, that is securing this data verification mechanism, and so on. No? So this is like unplugging from the DVM, no? From the voting V2 contract, and it allows to do these kind of things. We can also decide to discard the Oracle. This basically means that after the dispute is sent, this Oracle is going to resolve something. It's going to resolve false or true. But we can decide to just discard and not listen that resolution because we wanted this assertion to be asserted optimistically during the liveness period. And in the event of a dispute, we just don't want to, we don't trust or we're not interested in the resolution anymore. No? This could be useful, for example, where we don't want to wait for the resolution in the DVM, because I haven't described it yet, but how the vote works, we follow a commit and reveal pattern, and it occurs during 48 hours. So it takes 48 hours to resolve the vote. So a protocol implementing with us could, for example, decide not to wait and send a new assertion to be approved optimistically instead of having to wait the 48 hours. No? And shortcut by this means the voting resolution. We can also validate the disputers. So we could have, for example, a whitelist of disputers. Again, this is an advanced behavior that should be configured properly, and it's kind of responsibility of the project, no? Configuring these functionalities. So, for example, we could only have a set of addresses that can dispute. The escalation manager is the address of the escalation manager that by default is address 0, and the asserting caller is basically the message sender, no? Calling the assertion. Okay, so here we have the rest of params. We have the asserter, we have the disputer that is 0. I mean, we don't have a disputer initially. The callback recipient is the contract that receives when the assertion is settled. So, or when the assertion is disputed, this contract receives automatically, if configured, these callbacks, and so can react. The currency that we mentioned previously, the domain ID, the identifier, which is assert truth. The bond that, as I mentioned, should be a minimum of $250 or more. It's not settled at the beginning. The settlement resolution, it's the resolution of the assertion, no? Which is false at the beginning because it hasn't been approved optimistically yet. The assertion time is just current timestamp, and the expiration timestamp plus liveness. And that's it. This is what defines the assertion and what starts the clock, no? The timer of the liveness. And also, in the event of having configured an escalation manager, we can get the policy, and this is something that we're going to see later when going through the escalation manager smart contract, but this allows us to have specific policies per assertion. Here we defaulted them. Everything was set to false, but this is where we are querying the escalation manager and seeing if the configuration should be different for this particular assertion. For example, an assertion, we could decide to discard the oracle for this assertion in particular, or have a different set of a white list of disputers, all of the configurations that we saw previously. Of course, we have this, we pull the token amount from the message sender, which is the bond, and then we emit the assertion made event with all the information that we saw previously. Importantly, we are not storing the claim, which is an arbitrary long message, byte encoded. We are just emitting it.
That's clever, because otherwise you'd be storing so much information on chain, you would crumble under gas.
Exactly. Okay, sorry. Yeah, and that's it. No, as I said, and once this function is executed, the timer is running. No, and we have 2 hours in my example for the assertion to be validated and certified. No? But during these 2 hours, as we are economically incentivizing this mechanism, anyone could be watching and anyone could dispute the assertion with the intentions of getting a part of the asserter bond. So it is a lucrative action to be watching, and that's why this mechanism works. So let's go through the dispute assertion function, which is much simpler. So we only need to, if we want to dispute, we only need to pass the assertion ID returned by the assert truth that we saw before, and together with the disputer, which is the disputer address that receives the bonds eventually after the dispute. No, yeah, super simple function. We just check some addresses. The expiration time should, the assertion should not be expired yet. And the dispute should be allowed, no? Because these are the advanced configurations that we mentioned previously that could be set. But by default, every assertion can be disputed. And again, we pull the bond from the disputer. No? So at this moment, we have 2 bonds on the table, and this is where we escalate. This is a function that escalates the dispute to the DVM by default. This smart contract called voting v2 that we're going to see later. It's open here. So let's see very quickly the function signature. It is receiving these arguments, the assertion ID, the identifier, which is assert truth, and the timestamp, and it basically generates a message representing this assertion. So we are not sending the claim again. It is just the ID of the assertion. So we are not carrying this potentially super heavy information of the claim. And together with the asserter, so some informations that are sent to the Supreme Court, which is the DVM, so it can be decided in a decentralized way by the token holders. And finally, we have the first callback. The callback on dispute that is sent, nothing strange here, that is sent to the asserter or the defined callback recipient that we had at the beginning. In the event of having the escalation manager configured, we also send it to that contract. So we have two different callbacks. And that's it. Also, here we can see that if we decide to discard the DVM resolution, we are just kind of shortcutting the resolution of it. We can already resolve it as false, because even if the DVM resolves it as true after 48 hours, we are deciding not to listen or to consider this resolution. No? But this is not the default behavior. No? And we emit, as always, an event, no? Assertion disputed. That's it for the assertion. I can continue with the next one. If you don't have
thanks. That would be great.
Question? Okay.
It's quite simple and straightforward, I think. Even with the extra things, you explained it well. Thank you.
Yeah. Okay, perfect. Yeah, don't hesitate to interrupt. All right. So the settle assertion. This function can be called at any time, but should be called when an assertion has passed the dispute period. So it can be settled, or it has been resolved by the voting contract, the DVM. So it's a very simple function again. We only send the assertion ID. Again, some checks at the beginning. We just optimistically change the assertion to true, and then we have two possible scenarios, right? We don't have a disputer, meaning that disputer is still address 0. In this case, we just need to verify that the current time is higher or equal to the expiration time, no? Meaning that the assertion has expired without disputes. No? So the happy path, the optimistically approved path. Right? In this case, the settlement resolution is always true, because asserting is stating that something is true. No? So always true. And in that case, we can already send the bond back to the asserter. No? We only have one bond because we didn't have disputes. And again, a callback to the contract that was configured, no? As the recipient of the result as of assertion. This could be, for example, a smart contract, a prediction market, no? Receiving this callback, no? When the assertion can be used already and have some logic on top of it, no? Calculate some payouts or whatever. And again, an assertion settled event. But we have the second scenario where the assertion has a disputed address, right? In this case, we want to query the oracle, which is the DVM, the voting V2 contract, and get the result price. And here we can see again this int. It's like kind of legacy thing or backward compatibility with other oracles. That's why it's an int 256. This function reverts if the price is not resolved. No? So if it hasn't been resolved yet in the DVM, this function will just completely revert, and we won't settle anything. So then at this point, we just need to check if we have resolved price. And here we have the notion of price. This is like, again, a legacy terminology that we had in previous contracts that we are getting rid of, but we still use it here to be consistent and to be more clear, to us. But basically, we are only caring about if it's true or false, by comparing it to the numerical true, which is this one value. So if it's true, we store it as true. Otherwise, it's false. And here we calculate the bond recipient, because we are in this dispute scenario. We need to calculate the payouts and distribute back the bonds, depending on if it was true, if it's true or not. The recipient will be the asserter or the disputer. This is the Oracle fee. As I said, it is currently configured to 50%. So half of this bond is going to be sent to the store. And this, I already mentioned it, but it's kind of like the cost of triggering the bond, right? Yeah, I'm going to talk maybe about the reward mechanism that we have in the voting contract later. But this is supporting this rewarding mechanism, this constant emission rate of UMA tokens that we have. All right, so bond recipient amount is the remaining, the two bonds minus the Oracle fee. So in the end, it's currently 1.5 bonds that disputer or asserter get. And that's it. Just pay the amounts to the Oracle, to the store, and the recipient, and some final callback here, assertion resolve and assertion settle event. If discard Oracle was configured, we don't need to do a second callback because we already did it on dispute. No, this is something that we saw here. That's why we don't call back 2 times in that scenario. And that's it. That's it for the settle assertion. And this is in the end the life cycle of an assertion. It's very simple, as we can see, and very. I mean, I'm gonna show some examples, but very easy to implement with. Here we have more functions that are kind of wrappers of the previous ones. This one is just calling settle and getting the result, which is a Boolean, as I said, so true or false. And some functions to sync params, to update the cache. Some getters here, we can get all the assertion information with the ID. Here we can get the results. So all these functions are public. Anyone can get on chain the result of an assertion very easily. Here we have this wrapper of the block timestamp, some utility functions to stamp the assertion. So this is basically building the dispute message that is escalated to the DVM, the minimum bond, nothing strange here, the ID, simple hash, and yeah, some internal functions, just querying the finder to find the different contracts that we have in the UMA ecosystem. Now we have an address whitelist where we whitelist the currencies that can be used, the identifiers that can be used to store. This is the DVM or the custom DVM if configured to be so. This function is here to read the price from the DVM. The custom DVM should implement the same interface in the event of doing that. And yes, some functions to read the policy, etc., etc. I think it's a good time maybe to, as I've talked a lot about the escalation manager, and just we have some functions here fetching things from this contract. Let's maybe jump to the escalation manager interface, no? Which is this advanced configuration, if it makes sense, unless you have questions.
No, that sounds good. I've been wanting to see it, so let's dig in.
Okay, perfect. So this contract is, this interface is quite simple, and I think we've covered it mostly, no? But let's just go through it again. We have this idea of assertion policy. So each assertion can have a specific configuration. An assertion can be blocked for some reason. The protocol or person implementing can decide to block a specific assertion. That's on them. Arbitrate the escalation manager. This is to unplug or not from the DVM. Depending on the use case, it can be done. Discard Oracle. We already covered it. It's basically just don't consider the Oracle resolution. And validate disputer, this is to whitelist disputers, no? And constrain how the assertions can be interacted with, or yeah. Just a view function to get this policy. We pass the assertion ID. So we have different policies per assertion. And then these are just checking, again, more view functions, checking if the dispute is allowed. And this depends on also on how this EVM, this escalation manager, sorry, is configured. We have the get price. This is the function, the interface that we said together with the request price. No? This is kind of the legacy or backward compatible interface. So that we have in the DVM, no? So it can work with any optimistic oracle. The escalation manager should implement it if it's configured to be used as the data verification mechanism, no? For this particular, for this assertion. So it needs to have the identifier, time, and ancillary data, which is the equivalent. In our case, it is the claim at the end. It's the truth that is being asserted. Yeah. And so it's quite simple. We have an example of full policy escalation manager. This is, it's quite long, but this contract is showcasing how we can use any of these specific configurations, no? How to arbitrate resolutions in a different smart contract and the DVM, how to whitelist asserters, how to whitelist disputers, things like that, no? So I'm not gonna cover this contract unless you want. Maybe we can see examples of implementations, could be better. But this is here for anyone to be checked. And I believe this contract is very intuitive. I mean, it needs to be, of course, understood and spend some time on it, but it showcases the potentials of this escalation manager and how they can it can be used to different use cases.
That's really helpful that you guys made that. So that's contracts called Full Policy Escalation Manager, if you want to check it out. But I don't think we need to go more into detail. It's just good to know it's there. That's really helpful.
Okay, perfect.
Yeah, maybe some implementations would be awesome.
Yeah.
If you feel like.
Yeah, of course. Good. So I'm gonna jump to another repo that we have at UMA as well. It's a public repo. It is called Dev Quick Start OOV3, and I'm gonna show how to build some some contracts that use the optimistic Oracle v3. So
that's really exciting.
Let's start with the insurance, which is one of the most common use cases that the optimistic Oracle v3 allow. So basically, this contract is insuring anyone for events, right, that happen in the outer world, and so with insurance policies, etc., etc. So let's zoom in a little bit, and so this contract basically, as any implementer contract with the OO, just needs the interface to interact with the contract. Here we are storing the assertion liveness that we want to use, in this case, 2 hours, the default identifier, which is the assert truth, and the currency that this insurance contract uses, the default currency that should be approved in the OOV3. But in this case, it could be, for example, a stable coin, USDC, for example. Then we define the policy. And here we can see the insurance amount, the payout address, the insured event. So this is a byte encoded description of the event. Let's say an earthquake happened in some city, for example, and if it has been settled or not. And then we have a mapping storing these policies. Yeah, this is mapping from policy to policy ID, and sorry, from policy ID in this contract to assertion ID in the assertive, just for convenience, basically. The policies themselves stored as a mapping, and some events, basically informing about the life cycle of this contract. Again, quite simple constructor. We just passed the Oracle v3, the default currency, and that's it. And then we are ready to insure people by issuing these insurances. So by the way, this contract is not handling the subscription, let's say, to these policies. So it's just issuing them. So the cost, let's say, of being insured, it's not handled here. This is just showcasing how we can use the Oracle to insure and certify that an event happened and act if needed. So in this case, this function receives the insurance amount, so a number of tokens, the payout, so the address that is insured, that will eventually receive an amount of money if something happens, if an event happens. And here the event could be anything. Like I said, an earthquake or anything. And it returns the policy ID, which is how the policy is represented in this smart contract. Again, some checks, some regular policy already exists checks. Then we store the policy with all the information. And finally, we pull the funds from the insurer. So in this case, this function is called by the insurer, right? The money to eventually pay the insured, the payout address, is already in the smart contract, waiting for the Oracle to maybe call back eventually this contract. Then we have the second function, the request payout function, where anyone, this is, well, both are public functions in this case, but this is a public function where anyone can request the payout for a specific policy. And by doing so, this person will be saying, hey, this event has happened. So this earthquake defined in this policy happened. as defined in the policy, no? So at this particular city and date and so on. So I'm sending the policy represented by a claim to the optimistic Oracle v3 to stamp it and certify with the mechanisms that we described previously that the event happened. So it's just a wrapper of or using the Oracle v3. So basically, we just grab the arguments that we saw previously, the bond that was defined in the policy. So the caller needs to upfront the bond. No? This is how the Oracle works. We already saw it. The caller is the person that is asserting the truth in the end, no, to the eyes of the Oracle. So this person needs to upfront these $250 that will be sent back after the challenge window if this person is not lying, of course. So basically, we pull the bond from the sender, we approve the OOV3, so it can pull the bond from this contract, and then we call assert truth. Here we are calling the full version of the function because we want to be able to specify a different bond if needed. But the rest of and aliveness as well, and currency. But the rest of params are default ones. No, we are not using an escalation manager, also called sovereign security, and yeah, and that's it. No, we are creating the assertion. The timer starts. The 2 hours timer starts, and we just store the assertion ID associated with this policy. We're going to say something, I think.
No, I was just going to say that's really cool. I'll definitely, and hopefully our viewers will too, check out the dev quick start repo for Inspo of things to build. This insurance policy is a really good idea.
Yeah, yeah, and it's a very, very simple contract. So it's just 100 lines. With 100 lines, we can implement an insurance contract with the OOV3. The rest of functions are basically callbacks, no? That needs to be implemented and that we are using. In the event of the assertion being resolved, so we already described this life cycle of the assertions. So when an assertion is resolved, so whether it's optimistically or after the DVM resolution, this contract receives the callback, and so we can settle the payout. No? We can pay eventually the insured with the amount that is insured. And that's it. It's a very simple smart contract. We have more use cases that can be seen in this repo. I don't know how much time do we have left, but we also have a prediction market. This is a bit longer, but again, very intuitive in my opinion, very well documented, and we also have tests written in Solidity, so with Foundry, that showcase all the different scenarios that this contract have. And so with this contract, we are showcasing how to build a prediction market, no, to allow users to bet on things. No? Do you want to go through it, or what do you think?
I think our viewers can check it out. We're coming up on time, so
yeah.
I think
okay.
I'll look at it this afternoon because I'm very interested.
Perfect.
I really want to see it. But yeah, I think that was a really good overview. Thank you so much. That was really interesting.
Yeah. No problem. Just a quick mention to the data asserter. This is the pattern that we have to assert any kind of data because in the end, the optimistic Oracle v3 is asserting a sentence. No? We are asserting a message, but maybe if the contract wants to use a specific data type once an assertion is approved, for example, a number. No? If I'm asserting that the price of Bitcoin was $3,000, probably I will want to use this number, 3,000, once the assertion is approved. It's certified, right? So this is basically the way to do it. It's just showcase example, very, very simple, wrapping this assert truth function to be able to have this notion of or arbitrary data types, no, associated with assertions. So we are de facto we are asserting any kind of data structure. And yeah, ready to be checked here. Again, we have tests, and of course we are on Discord and very happy to help with any questions, any implementation issues.
Awesome, that's great.
Cool.
Cool.
Awesome.
Thank you so much, Pablo. That was so interesting.
Yeah, I think, yeah, we are exactly 12 o'clock. So that concludes this episode of Solidity Friday on Wednesday.
Cool.
Yeah, thanks so much, Pablo and Tam, for your time. And yeah, thanks so much, Web3 Sanctuary and Linum Labs for making this possible. So the video will be available and posted on Friday. So yeah, watch out for the stream, and we'll see you guys next week. And next week we'll be looking through WorldCoin, which is exciting as well. So
yes,
catch you.
and that'll be on Friday, like normal.
Yeah, let's see. We'll spring up surprises if it's on Wednesday or Friday, but next week will be Friday too.
Yes.
Thank you. Yeah, thanks so much, Pablo.
Thank you.
Yeah, and thank you to Uma. Such an interesting protocol.
Yeah,
See you guys soon.
Okay, bye-bye.